So this is a plastic wire which gets heated to a particular point, and then whatever it gets heated comes out as a molten liquid. So I would like to give an example of a candle. So suppose when you light the candle, so the wax actually melts. The melting of the wax happens because the fire melts the wax, and then once the wax comes to a bottom or once the wax drops down, it actually becomes into a hard wax. It will no longer be in a molten liquid state. In the same way, whenever the wire passes through this, it becomes a molten liquid, and then as soon as it comes out from the nozzle, it actually becomes a solid part. So the movement of how this nozzle should move left, right, and then how the bed should move, everything is happening through the slicing software, and that slicing software is happening here. So the human intervention required for this is very minimum. So once a CAD model is prepared, I would say less than 5 minutes is required to get this programming done. And just like traditional process, we do not have to know anything about the G coding. So all we have to know is like just select what way to print a part and then just click on one button which is print, the model actually gets executed. So now if you see the material gets deposited and then the nozzle moves in the X and Y direction so that it's being placed in the exact location. So all the working, all the principles would be simple to that of maybe if you use a 3D pen. So if you just move the pen from one direction to other direction, the material keeps on dipping. So wherever the material is dipped on, it becomes hard as soon as it leaves the nozzle. So here we have two versions. One is we have version which is single nozzle, and we have something called as dual nozzle. So dual nozzle is something like which can print complex geometry parts. So now, for example, if you look at the image, there is a blue wire and there is a light blue wire. So this light blue wire is actually a water-soluble material, but it will be printed along with the printer. But as soon as the printing is done, you just dip it inside the water and it gets dissolved. So here, once again told line, we do not have to worry about how it will actually coding or what kind of process has to be done. Everything will be taken care from the software form. So here, all the things that we will have to consider is, so here you can see just the black part what you see over here. This is actually an ABS material, which is the actual plastic. So the white material what you see over here is actually a support material, which is it just dissolves in water. You just dip it inside the water for some 4 to 5 hours of time, it gets completely dissolved. So this is one example why we would say 3D printing has got a very huge advantage with kind of design complexity. Because if you just look at this image, the black image, so there is no way that we could have manufactured this in just one cut using any of the traditional process, because this design is completely hollow in both the directions and it's having lot of inner cuts, it's having lot of internal cavities. So we would have to use a tool which is very curvy tool, but even then we would not be able to do the drilling in such a complex design. So usually in traditional manufacturing, what we would have done was split it in two, do it separately and then join it together. Whereas in case of 3D, any complex geometries can be done, and the time required for doing such a complex geometry was like almost close to 8-10 hours. So we just give the print overnight, we come back tomorrow morning, the model is ready for us. And we can directly fit it into any of our equipment and do the testing. So that if we were assigned a job today morning to check whether this model performs, by tomorrow morning we can tell our administrator or we can tell our IR manager that this model will function or no, we have to change. So we can directly tell them in 2 words. So I just play a small video of this FPM printing. So here you can closely observe, so the nozzle is actually dipping a green color material. So this means that a green color filament wire is actually getting heated over here, and then as soon as it gets heated, the material is being deposited. The deposition rate and the speed of which the nozzle should operate, so everything is predetermined by the slicing software. So here if you can see, as soon as it completes one layer, the z-axis moves down and then it prints the second layer on top of it. So it just prints layer upon layer again and again till the model is completely prepared. So this would take somewhere close to around like 1 or 2 hours, but we will get our required geometry. So now let's say this is one of our tire design. So we would actually be able to see how actually the tire would look like and how what are the different changes which we can make. And suppose now we have given a very smooth outer cover, we can actually change this and make it into as per the tire design. Now, this was about the FDM technology. So now if you go to the second technology, polymer. So FDM is a process which makes use of plastic wires. So you can just keep it in that way. And plastic that can be used day-to-day plastic which we use in our life. Like for example, we use PP, which is a very much for which we use it for our water bottles. Similarly, we use like materials like PLA, we use materials like ABS, we use materials like even like nylon, or we can also use materials which can directly be used in the aerospace segment. So that is one of the reasons why we can say aerospace segments prefer 3D printing is because there are plastic materials which are approved from the aerospace organization so that you can directly 3D print the parts and fit it inside the aeroplane and make it run. So we don't have to wait for very long time in order to get the parts. We can directly 3D print and fit it into the aeroplane and then it can be used. We have got some examples from Boeing, we have got from Singapore Airlines, so there the parts are directly 3D printed and fitted into the aeroplane. So the second technology would be a polyjet based technology. So this is a technology which makes use of liquid resins, but the operation is something similar to our inkjet printer. So it actually sprays the ink. So the inks are sprayed in such a way that so wherever we require the model material to be deposited, so the inks are sprayed in that direction. The advantages with this technology is you can get a part with multiple colors. So it's similar, as I said, like it's similar to 2D printer, like an inkjet printer. As you all know that in inkjet printer we have CMYK color. So mixing of the CMYK color, we get lakhs of other colors. Even in this printer, we have liquid resins which are in CMYK color. So that cyan, magenta, and yellow mixes together, and then we get yellow, orange, blue, green, whatever color we require. So here is the that UV resins are UV. So the liquid resins are actually sprayed as a ink droplets. So the ink droplets, as soon as it gets deposited, then UV light passes over it. So just play a small video regarding that. So one better example would be like if you're looking at the screen. So the blue lines are something which is similar to an inkjet head. So the inks are getting deposited over here, or in 3D printing terms, we can call it as like liquid resins. So once the liquid resins are deposited in the required area, and UV light passes over it, so that it gets completely dry. Because here UV light is used for solidifying of this object. So small.
See that printer.
Now it's first scanning, right?
No, printing. From top, these are all spinning to the holes.
What?
Very light polythene, that liquid polythene, it is dropping down.
To make a shape, right?
That shape, whatever you want. So slowly it starts precipitating. It starts making easy. Thickness is increasing.
But how does it even increase?
No, it is dropping down from top.
It drops down from how many holes it's there?
Okay, so just to see overview of this.
Even though you know about the laser cutter?
There is a liquid droplet which gets deposited on a particular area.
Do you know
where
about
exactly which color has to be
laser
deposited,
cutter
it will
is
be
very
pre-calculated
cheaper.
from the software.
It's twice as
Here if you
cheap.
can see, it prints the first layer. Now let's say the first layer, and then after the first layer is printed, the UV light passes on it so that it becomes completely dry. And then the bed moves down and the second layer is deposited. And then once again the bed moves down, the third layer is deposited. So here, similar to FDM process, so the technology remains the same, where actually after the first layer is printed, the Z axis moves down and the next axis is printed. But the only thing is there in FDM technology, we are using plastic wire, and then if you want to print a circular object, the nozzle has to move throughout. Whereas in case of polyjet, if you want to print a circular object, we are just going to pass the edge from one end to other end once. So the model gets deposited. So in a way, polyjet technology is somewhat faster than FDM. But coming to a point where it's only faster when we are comparing or when we want to print multiple parts. So the reason why we can say that FDM, polyjet or the other different technologies, when the different technologies are being used, is completely upon the application. So when we say about applications like using polyjet, we can make parts something like this. Which are completely colorful. So this is the only technology using which we can make very colorful objects ready from the printer, because all the other process, it might be an FDM process or it might be even SLA or SLS, which we will discuss later. So even those utilize only one color material at a time, whereas this is the only process in which we can use multiple colors. Like for example, at a time we'll be able to print more than 5 lakhs to more than 10 lakh different colors. If you just look at the screen, like a colorful spectacle is being printed, and this has somewhere close to around like shades from light green to dark green, so it has got very different shades in it, so which makes this a very unique kind of printers. And of course, these printers also have some unique applications. These printers cannot be used for like our simple prototyping needs or for our simple jigs and fixtures applications. These are printers which are used especially in the animation industry. These are printers which are used in like consumer products. So those industries who prefer aesthetics as their main goal. So if you go to the next technology, which is SLA, or called as stereolithography. So this was the technology which was invented in the year 1988. We could say that this is the first 3D printing technology which was invented. So this technology also makes use of liquid resin. So the liquid resin would be something like it would be having very high viscosity, so that the model is very thick enough. But as soon as a UV light, or let's say an example like as soon as the sunlight falls on it, the area where the sunlight or the UV light falls, it actually becomes solid. So it follows that kind of principle. So an example would be like, if you can see on the screen, like the green color platform is actually the plate and the model is placed on top of it. So here, similar to other technology process, wherever the model is required, the laser light falls only in that particular area. So wherever we do not want any model or if there is any hollow object, so laser light will not fall into that area, so that the area will not become bright. Example would be like, you can see the complexity here. So models such complex as this cannot be done using any other process. It can be done only through 3D printing and especially through SLA process. The reason being, we do not have to worry about the post-processing so much, because it's a liquid resin which usually flows out. And the second thing being, the laser light falls in exactly the required direction, making sure that the accuracy of the part is very good. So, you can play a small video related to that. So here, if we just have to give brief, so the material which is provided over here is actually a material which is, we call it as like wet material or a liquid resin. So whenever a UV light or a laser light falls on it, so this material becomes solid. So now let's say it's a completely liquid state. So
అరే ఇట్రా
A laser beam is actually passed and then it's being
ఇందా మటనాడి నుంచి వచ్చిందిరా
focused to an area where we would require model material.
Yeah.
So the area where this laser light
Right.
will fall is actually directed
Mutton
from
ekkadi
the
chestunda
program
ga?
that is already being generated through slicing software.
ఆ?
So here we can see that we
mutton?
want this particular object to be complete solid, so the laser light is actually driving in this area. So now,
Hello?
of course, like even in this technology, there has been a lot of
Hey.
upgradation. So this was the earlier process where laser light actually
Mutton
falls
ekkada?
throughout. So now we have something called as flashlight. So now the entire area is completely like
Ekkada
an
anna?
LED flash, so that the flash happens once. So as soon as the
Yes,
flash happens, the entire area gets solidified. A process where the laser light has to pass throughout can also consider as a flashlight process. So here the laser light falls through and then the model gets solidified. So once the solidification, once this
నేను వద్దని చెప్పిన
particular
తర్వాత
layer is
మళ్ళీ యాడ్ నుంచి
solidified,
వచ్చింది
the bed moves down. As soon as the bed moves down, what happens is the water, the liquid actually comes on the top surface. Maybe a particular amount like 50 microns is
ఇట్రా
still
ఒకసారి
coming
నువ్వు
up.
డబ్బులు ఎంత ఇందా ఇట్రా
So an example would be something like if you take out a full bucket of water and then you place your hand on top of it. Just don't immerse it and then just slowly immerse your hand. You might feel that the water coming on top of your hand. It's the same process over here.
Inquiry
So here,
ఏంటి?
as soon as the top layer is solidified, the
ఎవరిని?
bed moves down. So once the
నాకు
bed
అసలు
moves
వినపడలా
down,
నేను
a
వద్దని
little
చెప్పిన
bit
తర్వాత
whatever
మళ్ళీ
liquid is
ఎలా
remaining will
తీసుకుంటావు
actually come on top of it. So how much the bed has to move down, how much the liquid will be coming on top will actually be calculated using the software analysis.
అదే అదే తలుచుకుంటా ఉంటుంది ఆ లోపల
So now the elevator, so the
పిక్చర్ ముదిరిపోతుంది
the liquid comes on the top.
ఎవరికి ముదురుతుందో చూసుకో
ముదురుతుంది
So as soon as the liquid comes on the top, the roller is used to make sure that it's a completely flat surface, and then the next layer is printed on top of it. So that layer by layer, if there are some 1,000 layers that has to be printed, for every 1,000 layer it's printed, and then we get the end part. And coming to the last process, which is SLS. So this technology can either be used for like plastic powder.
తీసుకొని చదువు అసలు ఇంతవరకు ఏందో నాకు అర్థం కాదు ఇద్దరు ఎలా తయారంటే
like metal 3D printers. So this
సిగ్గులేదు పడుకుంటా
almost
ఉంది
90% of the metal 3D printers follow this principle, which is powder-based process, in which there will either be a metallic powders which are very fine grilled, or if you're talking about plastic, it will be of like a nylon powder. So that the powders are very delicate. It will be just like the powders that we often use. It might be either like powder which we feel it in our hands, or it might be even like a chalk powder. So those are the powders. But here the things are like, for example, if you are talking about even from HP where they have like MDF technology, it will either be like a binder jet where glue is being deposited on top of the powder, so that for example, you see there is a powder deposited. So this light can either be a laser light, or it can either be a binder jet,
మటన్ కానీ
or
చికెన్
it
తిని
can
చెప్తాను
either be a high intensity laser. If it is a metal, if it's a metal, what's going to happen is, so that laser light is going to be such intense, so that
ఎక్కడన్నా ముక్కల కోసం పరిగెత్తాలి చెప్తాను ఇప్పుడు
similar to welding process. So the powders are going to get
బయట
welded
నుంచి ఎవరు
together
వచ్చినా తినొద్దని చెప్తున్నాను
is going to be sintered. So if it is a powder, then it will just be a binder jet, so that as soon as the gums are being deposited, it actually sticks to it. Some example would be similar to this. So now let's example, these are the small powders which are at a fine distance from one to other. But as soon as this laser light falls, because of the heat of this laser, they actually merge together and then they actually form a one individual part. So if we, let's say if you wanted to make something like a chessboard pawn,
బుక్ తీసుకోరని చెప్తే వినపడతా నీకు
that's the area where the laser light actually falls. So only those areas would be becoming very hard, and the areas where the laser light will not fall will be still in the powder condition, so that it can be reused again. Something like this. So the only area where the laser light falls, it's getting solidified. So it can either be a laser light, or it can either be a binder jet, or sometimes it can even be something similar. Sorry. Or sometimes we can consider as a process where if you are going with a metallic portion, then it is going to be a laser light which is of very high intensity, so that it can even like melt the metal powders and sinter it together. So it's a small video related to that.
3D printing ఈ పక్కది
electricity or geometry. Build chamber, roller, collection container and the meaning.
కలెక్షన్ అంటే తీసుకునే కంటైనర్.
So this technology, I would say, it's similar to that of an SLA, which we saw earlier with the liquid. But here, since it's of powder, so we cannot go with the same concept. Like if we just dip on the powder, the remaining powder will not come on the top. So what we'll have to do is like we dip this as soon as the first layer is printed, this bed moves down, let's say around 100 micron, and then the next tub is actually deposited on top of it. So we make sure that after the first layer is printed, the bed moves down, and then the model is ready for the second layer. So it's a complete process, and once again, like this entire process is completely driven. So these are the four major technologies of these 3D printers, which is FDM, PolyJet, SLA, and SLS. Of course, like to just be like the working principle. Suppose if you would like to know more details regarding this, we can always get in touch and discuss more related to this. Or I believe like maybe we can discuss more in our further sessions. So here the main principle of what we are just discussing about was either it is an FDM process or an SLA or SLS or PolyJet. So when and how is this technology used plays a very major role. So a part which can be manufactured from SLA can also be manufactured with all the other processes. But sometimes a part is best fit only when it is manufactured in SLA. For example, let's say we want to use it in our working environment, we want to use it and for a training of our students, we want to use it inside a designer cabin, then FDM is the only technology which is possible, because all these PolyJet, SLA, SLS are considered as industrial grade printers because there are a lot of safety that has to be taken for. Because here we are talking about powders which are very micron sizes. So obviously we will have to wear a lot of health safety, suit and gloves and mask, everything has to be worn in order to just operate in front of it. So it requires a dedicated place for operating the other three technologies. Whereas in case of FDM, it's a process which can be operated from any place. It can either be placed now, for example, you're just listening to a presentation, I can place a 3D printer next to me and start the printing, and the sound will not even disturb me. That will be the kind of technology we are talking about in case of FDM. So if you're talking about applications, well, the applications of these technologies are divided majorly into 4 different aspects. So one is the concept models, which is the functional. So concept models are something like it might not be an end product at all. It will just be an imagination from our mind. Now let's say I'm thinking about some smart glasses and I want to make a covering for them. It just comes to my mind, I can make a concept, I can actually design it, and then that can be 3D printed and I can see how it looks. Or it can either be used for like functional prototypes. So maybe whatever I have designed, I can actually fit inside a vehicle and see whether it actually fits in exactly. Of course, it might not meet the requirement of temperature or it might not meet the requirement of vibration, but I can see the fitment testing. In some cases, I can use almost similar kind of material so that it even matches the temperature, strength, vibration, everything is matched so that it actually performs like an end product. And it can also be used as for manufacturing. Sometimes it can also be used as for the end product. For example, let's say I'm coming up with a product launch which has got only 50 numbers. So I can directly 3D print those 50 numbers. I do not have to do any kind of tooling for them. So as you know, the one advantage of 3D printing is it does not require any tool. So whatever we have designed through CAD model, it can directly be 3D printed without any tool. So now I just want 50 numbers. So I can do the calculation telling that, okay, now if I make the tooling and get the product done, it might take me somewhere close to 1 lakh. If I directly do the 3D printing, it will cost me around 80,000 rupees. So it's going to save me cost, but I can also see the time frame. If I have to do the mold process, it is going to take me 2 to 3 months. So 3D printing, I can get it in 1 or 2 weeks. So we are talking about the huge difference of time. So around 90% of the time we'll go for 3D printing option when both time and cost are beneficial. So some other applications would be either its concept or design or for manufacturing. There are huge applications. Of course, like discussing of this application to take a complete session. But just to give you a brief overview, so as I told earlier, like I'm just showcased through few of the slides where how department wise, like we need to which department, what all parts can be done to educate students or to train students, other students can learn some idea related to this. So I would like to discuss about the stage in which the 3D printing is being used. Like for example, currently many of the organizations are using 3D printing at the end stage. End stage in the sense after the tooling is done. So where they do not have 3D printing or where they do not do prototyping at every stage, so that they do the designing only at the end stage, and then suppose if there is any error, then what's going to happen is like once again it has to be sent back. So now, just to give you a brief overview, let's consider in one of our lab we have asked the students to perform a particular task. So let's say this first task was to collect a certain chemical of like some 2 ml chemical of NaOH and 2 ml chemical of other chemical, and then mix it together. So now in the first stage itself, instead of 2 ml, if the student considers 3 ml, the entire result would be wrong. So that it's a similar kind of example where the student can cross-check each and every time. Like for example, 2 ml of NaOH, he can just take 2 ml of NaOH and then he can just cross-check it once. That cross-checking is what we call it as prototyping. So if we do not do that cross-checking, what will happen is you will end up with a wrong result. So that you will have to do the entire process once again. But suppose you have to do the entire process once again and then you come with the result. But let's say in this case, what's going to happen is it might be in the industry point or it might be student point, he will be late. And as per in the industry market, what we are going to say, if you are late by 6 months, we have already lost 66% of our profits. So now suppose imagine like a student or a designer, as soon as he takes a 2 ml of liquid, he just cross-checks it. Or a designer, as soon as he designs something, he 3D prints the part and sees how it looks like. What's going to happen is, and when they come to the final stage, the product will be 100% good. They can directly go for the manufacturing. In this term, it is going to affect in terms of cost. Because in the early 3 stages, it will only be in the designing stage. So they will not have implemented too much of cost. They don't have to implement too much of cost for molding. So that even if they make any errors, it's only minimal error. But once they go for the tooling stage, where they are going to take around 2 to 3 months, and then if they come up with the error, it's going to be a very huge loss. And then once again, why 3D printing is required? One is because the cost of error, you can identify the error at a faster rate. It compresses the time, creating and confidentiality. So if we're talking about students for jobs of today, so many companies are having difficult time finding candidates with right skills, because every time they have to take the candidate, they have to train them completely from the scratch. And any graduate 3D printing experience is more attractive to employers. And if universities offering 3D printing experiences, students would be attracted even to the universities. So it's a vice versa project. So if graduate companies are looking for 3D printing skills, and if university is offering that 3D printing skills, will attract the students, and the same way it will also attract the companies for the placement. Universities adopt new technologies which students can bring into workforce. Companies adopt these new technologies and are looking for graduates. So as I said, it's completely a vice versa process. So universities would like to adopt to new technologies, and companies are looking for universities who have adopted to these technologies. So we want the survey done. So it's the same process which we discussed later, like which technology would be having high growth. So here we can see in academic section, it's having 8% of the overall 100%. However, 8% is not a lesser margin when we are comparing that in aerospace or an automotive industry has got 15 to 16%. So let's imagine a case where this academic reaches more than 20%. So it will directly be a relation between every organization with the academy. So now I will go back to the FDM technology, which I will like to show a few of the examples related to this. So this is the same prospect where a liquid filament is, where a plastic wire is taken, plastic wire is melted, and then the melted plastic wire is actually deposited in the particular areas where it is required. So it's a small video related to that. This video, if you can see, there are two materials that are printing together. One is the black material, is actually a plastic, and this white material is actually a support material, which can either be water soluble. So once you print the part, we dip it in water solution, it gets completely dissolved. So here we are talking about a technology which has got two nozzles. So two nozzles means one actually prints the plastic, and one actually prints this white material, which is water soluble. So here, if you can see, this model was something designed through CAD model. So now I can either print these separate parts and then assemble it together using a single extruder printer, which is, I would say, desktop printer at a much affordable rate. Or if I go to one level higher, which is an industrial grade printer, which has got two nozzles, which can print any complex geometry. So it can print a part something like this in one go, and then I can dip it in water. This white material gets completely dissolved in water. I will end up with a part something like this. And if you say about like the different applications where technology used, it's almost the same examples like automotive to product line, production, to rapid prototyping, packaging industry, flexible manufacturing parts, medicinal parts, architecture. So now the industry focus is completely, I would say, every industry. There is no such industry which we cannot say that 3D printing is not required for them. Even in the healthcare segment, in the biomedical segment, 3D printings are used for a very huge number. So I just take some few minutes to showcase the examples in different departments. So the subjects showed over here might be different because these are the generalized subjects which we organized considering all the terms conditions. So see, from Maker Board, we have something called as Innovation Lab setup. We recently set up two of the labs in Tata University, and we also have mini lab setups in almost like more than 10 colleges in Bangalore itself. So now we are talking about a plan where how manufacturing industry or how mechanical engineering students can be taught using this 3D printing. So one of the simplest example which I would like to say was like an engine, 4-stroke engines or maybe a 3-stroke engine. So now like how actually the working happens. Now usually what happens, we teach every student just through the diagram which is on the left. So it might not be very clear to the students every time about what we are trying to explain to them until and unless they come to the lab and actually see it in live. But not every university will be having that facility where they have a 4-stroke or 2-stroke engine provided, so that it might be difficult for students to learn. So now let's imagine a part where 3D printed this entire prototype, and then you can just take it to the classroom. You can just tell them like, this is how the engines will happen. So when the first stroke goes up, the second stroke will be over here, third stroke will do the following process. So an entire process will become crystal clear. And then similarly in case of CA analysis, so teaching the students at a lengthy step using all this CAE, we can just make a small demonstration and then tell them like once we pull it, the huge number of force will be applied in this area. So that is the reason why there is a red light and there will be no force applied in this region. So it's a blue light. So you can just give them a simple example so that it will relate to them very equally. Or might be in case of like, consider example of a differential gear, like how actually a differential gear working happens. So just by looking at the diagram, we can say it looks very complicated. But if we have a 3D model out of it, or if we make the students do a single project out of that, it will become very clear for the students. Maybe even the crank hook. So similarly, we have got numerous applications when it comes to like mechanical engineering segment. It can either be a gearbox, or it can be a brake, or it can be a V8 engine. Formula One cars can also be prototyping can be 3D printed. So the examples will be plenty. So one such example would be like plastic car discussion. Like for example, if there is anybody who's looking for like making of old cars or any car that has to be demolished, so those kinds of things can be done. So this is how the industries are actually performing. So industry, they actually take one of their classic vehicles, they try to redesign it. So 3D printing would be a better output for them. And of course, prototyping would be a major application. Prototyping like something like this, where we can see just the internal view. So forget about all the outer sketches. We're just talking about how actually the internal parts or internal design would look like, where actually the battery would be placed, where actually the engine would be placed, something of the analysis. Or maybe an analysis of the entire vehicle, or might be in the manufacturing segment where we are talking about fix and fixers applications, or any applications in which metals can be replaced with plastics. So we're talking about those kinds of applications. Or we're going for the next segment, civil engineering. As you know, civil engineering is completely related to architectural stuff. So we can relate it to CFD analysis, or we can go to like structural testing, how these kinds of testing can be done, because we have got numerous organizations or numerous companies in India alone where they do the internal testing for huge objects. So we have got one company in Kerala who has completely utilized 3D printers, and they have done the internal testing of Sardar Patel statue, and they have also done the internal testing of this Ram Mandir will be constructed. So all these things require the CFD evaluation, structural test analysis, but 3D printing are actually the best way to do that, because they can print a hollow structure, they can fit in the sensors, and it can easily be performed. So here is a small evaluation of a Rotterdam bridge, which is scaled down 1:1,000 times just for the CAE validation. Or might be in the civil or in the architecture, we are always used to see on the paper what is actually going to look like, but we can actually 3D print a small object and place on top of it. Maybe something like this. Developments can be 3D printed, architectural models can be 3D printed, structural engineering, structural planning, dams, shipyards, bridges. So here is a small New York City skyline that is being 3D printed. So here you can see like completely functions on its own without any worries. So a maker board printer can be placed next to your workplace, and then as soon as you are performing your job, the 3D printing will perform its job, and then at the end you will end up with such a beautiful kind of 3D CAD model. So in an overall time of around 8 hours, so you will be able to get a skyscrapers of the entire New York City. Or as I said, like these 3D printers are also being customized and they are doing it for their jobs. One of the examples were actually 3D printed houses. Of course, 3D printed houses are completely a new concept to what we are actually generally discussing. But even here, it's the same process where if you can see, instead of plastic wire, here the concrete which is being mixed with cement, sand, and some few chemicals for binding is actually being deposited, and then it works on the same process. It works overnight, over day. Around some 2 to 3 days, we'll be able to construct such a huge house, which current process is not at all possible. So we're talking about something which is very new and is already being in existence. Of course, these printers are all completely customized, but there are things happening even in the construction of houses. And of course, aeronautical, we have got completely a different platform, not related to either mechanical or through automotive, completely like stuffs which are completely to the aeronautical elements. It might be something related to like fuselage, so how actually it's going to look like. So of course, every student would not be having the opportunity to go into some aerospace companies and have a look into that. So they can actually 3D print and see how actually it would look like. Maybe a small demonstration of that, or might be a cut section of the engine, just to give them an analysis of like how an aero engine maintenance would be done, how an aero engine actually looks like, or maybe a wind tunnel, or might be different gliders. So as we all know that drones are actually part of Industry 4.0. So different kinds of drones, gliders, propellers. So all these things can be 3D printed. So a student who is doing his final year project has to come up with a new kind of design. He can actually utilize these 3D printers and come up with the most better design. So, of course, when you're talking about aeronautics, NASA and even our ISRO has been considered as a very huge organizations who are using 3D printer. So, it's one of an example where Rolls-Royce actually have 3D printed a final engine component and fitted into the vehicle and it's being run. So, of course, one of the reason was when they were going for traditional manufacturing, the entire set consisted of somewhere close to around like 12 different objects. So now it was shut down to just one. So now we are not talking about the entire part, but maybe a small object where it's being completely replaced. Or we are talking about a section where it can be used as fixtures for marking. So earlier they would have to have a slab which is of around like 10 to 20 kgs where actually robotics would have to handle these kinds of tools. But now it can be 3D printed in plastic, it can be placed, and the overall weight of this is somewhere less than around 200 to 300 grams. And in electronics industries, where it can be massively used for robotic arm applications or even printed wave patterns. So robotic arms are something where it's completely related to the electronics in it, but until and unless there is an arm to hold something, any kind of electronic device that you have done will not prove to be a robotic arm. But instead of just using some wooden sticks and clays, you can actually 3D print a robotic arm which actually represents a human hand. Or if you are making up any quadcopter or drones, you can actually give with completely new look, which can make a very aesthetic, better design. I'll just take 5 to 10 minutes more. Sorry for the delay. So robotic arms, mini skateboard, or even antennas, or even wave patterns. So as it is required for the examples of your students, or as it is required for your education term, or it might be for like different versions of drones. So the drones might either start from a smaller version to a bigger version, or you can come up with a new designs for that, so that you can make sure that it flies faster, it goes to a very large range, or it can be even considered for these electronic enclosures. Because as soon as whenever we do any electronic parts, we have to give some enclosure for that. So we'll have to, if we can make it with a much better design or much good looking parts, that aesthetic plays a very important role in any devices. So aesthetics also will be covered along with your circuits or along with your electronic components. We also have something related to material science. I'm sure like material science would not be a major topic in the engineering segment, but still, even it plays a very major role when you're testing of any bigger equipment, or when you're doing any CFD simulation kind of stuff. So it can either be considered either for like distillation purpose. So as per our kind of work job, what we are doing, so we can relate to that. But as I said, like the second major thing what we saw in the discussion was like apart from aerospace, the second was the healthcare segment. So biomedical and prosthetic arms are having very huge trends, and 3D printings are the best way for this. The reason being the CT scan analysis. So after the CT scan is getting done, so the doctors usually evaluate only by looking at the X-ray. But now we can actually 3D print whatever the CT scan is being done, the DICOM software can be evaluated, and then we can actually 3D print that exact part, so that the doctors can get to know what is the better way to operate, or the doctors will be able to explain to the patient that this is the exact problem what you have, and this is how we will be solving our problem, so that the patient would not have to worry so much about his illness. So it can either be like, for example, if there is any bone or any of the things, or if suppose if any surgical planning or testing has to be done, that can be conducted very easily. Or suppose some redesigning has to be done in some maxillofacial. Suppose if somebody has to go some nose job done, so that they will have to do the complete changeover. So instead of just doing it on the patient and see how it looks like, the doctor it can actually practice on some 3D printed parts or bionic arms. Those are the best things which can be used for any person who is handicapped. So prosthetic arms or bionic arms are very much in use for recent times. So orthopedic implants, braces, even for the dental applications, for surgical planning, for spinal implants. So through metal 3D printers, we have got a material called as titanium. So which can directly be implemented inside a human body. So suppose if somebody is losing a bone is being broke or bone is being fractured, so that directly instead of just using the regular process, they can directly 3D print as per the human body shape. So they can 3D print the bone marrow as per the human shape, and then they can actually place it and they can actually do the remaining procedures. Or one of best examples would be like it can either be in the film industries or it can either be in case of like suppose if any boy or any patient is providing like they do not have proper hand functionalities. So a 3D printed bionic arm can be used for them to do their daily day-to-day job. Or it can also be used for pre-surgical planning models, like suppose any heart implantation or any heart operation has to be done. The particular model of the patient can be 3D printed so that a doctor can get a better view of all the sites and they will know what is the better way to operate. And dental industry is having a very huge market. So dental industry, one of the major applications would be like it can be crowns and bridges, clear aligners, surgical guides. So these are some of the medical applications where, of course, like in the engineering segment, it might be very limited, but there are few engineering colleges who are actually into this biomedical kind of stuff. So it's having a very huge growth. And so these are the different applications of departments. So there are still plenty. So I would like to just give an introduction on the MakerBoard products. So these MakerBoard products are the FDM desktop printers, which can be placed next to your place and operated very easily. So they have a camera inbuilt. It comes with the extruder so that you do not have to worry about the functioning or working of the process. So this is the software point where we can see any kind of complex model geometry will be actually sliced without any issue. And the model, once it is being sliced, it can be sent to production. A small 1 minute video, so it will not take longer.
అసలు చదవమంటే నాశనం.
ఏంటి
నీకుంటే నీకు ఇలాగే మాట్లాడుతుండే నేను ఒకరోజు కూర్చుంటా నీకు మళ్ళీ
నా ఫ్రీ టైం అంతా స్పెండ్ చేసేది.
Okay, so I believe this should be sufficient for the day. So I'll just go through the. So this is the MakerBoard mobile app. So these are few education institutes where 3D printing is already being implemented and now they are utilizing it. So they've been utilizing it from a very long time so that they can get a very out of, or it can be either through the industry point. So, okay, so I would like to end my session here. So 10 minutes delayed, so sorry for that. So suppose if you would like to ask anything related to this, I'm sorry for the delay in time. So
if anything, I would like to thank you, Mr. Suman. That was an excellent presentation regarding the